This is J1, and welcome to the HSC Club. Today we're going to be learning about passive buzzers. So, what are passive buzzers? Here's the brief information about passive buzzers. Well, first, let's start with a physical appearance comparison between passive buzzers and active buzzers. Notice the differences between the two bottom buzzers. Compared to the active buzzer, which is no electronics visible on the bottom and covered by a black coat, you could see the circuit electronics right at the bottom of this passive buzzer. All the top views, regardless of both these buzzers, are just the same. Here's another difference between those two. An active buzzer will generate a tone using an internal oscillator. So basically, all that is needed is a DC or direct current voltage. For the passive buzzer, you need an AC signal to make a sound. That being said, the AC signal, also known as the alternating current signal, is like an electromagnetic speaker. In the electromagnetic signal, you control a changing input signal to produce a sound rather than producing just a tone automatically. Long story short, to identify them, if you apply a DC voltage to them and it buzzes, then what I'm saying is that it's an active buzzer. Otherwise, it's passive as far as commands go if you want to control that pitch. Our today's project is the Arduino keyboard. The materials required include one passive buzzer, 7 push buttons, one Arduino Uno, one resistor, 220 ohm, and 17 jumper wires. Here is the schematic of my project if you want to look at it for reference. Okay, now let's start coding. Wait, very important tip here. Here is a special note that you must pay attention to and definitely not skip in this video. Before you start coding, I highly guarantee that you download the pitches.h library and add it to your Arduino folder before starting the code. Without this, your code will definitely get an error message, for sure after you run the program. You can start downloading the file from the link in the description below this video. Please pause the video and try it out. When finished, you can go to the next step. Now moving on to the next part. To add the library into your Arduino program, follow these 2 simple steps. Step 1, click Sketch on the top left corner of the Arduino tab. Then go to Add File at the very bottom of the context menu. This is what you should have so far from all those 2 steps I've instructed to you. Now click on it and scroll through all the files until you find the file that says pitches.h. Lastly, click Open and you'll see that this file has been added. Now it's the time to code. Let's get ready for it. We're going to start with hashtag include pitches.h. Also, all the nodes are going to be stored into this library. And this is why we have this pitches.h file. That way we are able to get all these notes so that when we run the code, there is no error. Okay, so let's create the 7 variables starting from C, D, E, F, G, A, B. So you know, those are all the music notes that we use to play on a piano, violin, or any other musical instrument. Let's start with int c equals 7. And it's going to be the first button on pin 7. Int d equals 8. Second button on pin 8. Int e equals 9. Third button on pin 9. Int F equals 10. Fourth button on pin 10. And so on. Okay, so now let's create the next 7 arrays. And each array is going to play a note based on the letter. So, for example, let's say int C. And by the way, the brackets mean that it's an int array. Equals braces n C5. So this plays a C note. Int D array equals braces n underscore D5. This means that it plays the D note. And for all the rest 5, keep going. Int T equals braces n underscore E5, and so on forth. Oopsies. Alright, this is what you should have gotten. Alright, let's move on to int duration, parentheses 500. Every note lasts 500 milliseconds. You can change it like any way you like. It doesn't have to be exactly 500. It could be like 1,000 or even longer, or maybe even 250 or even shorter than that. Void setup. In this method, you're going to set every button as an input pull up. So I'm going to explain that in a second. So keep going over the code and follow along with me. Here we have pin mode, C, and input pull up. And then pin mode D and input pull up, pin mode E, input pull up, and keep going until it's B. Lastly, we're going to be on void loop. And here, we're going to read the button state when pressed. Start with if digital read for each button, right? So first we start with C. And if that equals low, what we need to do is make a for loop stating for int note equals 0, note is less than 1, and increment notes by 1. And then we create the tone method, and the parameters will be 6C of note and duration. Just to tell you and explain more about this method, the tone method actually plays the notes on whichever pin you put in, and that's where the buzzer is connected. For example, this tone method over here plays a note on pin 6 where the buzzer is connected. And then we repeat for all other 6 notes. So if digital read D equals low, then for every note less than 1 that increases, we basically get tone with all these three parameters, 6, D of note, and duration. Lastly, we will start using all these Arduino pieces to finish making this project and match the whole schematic in a couple previous slides mentioned in this presentation. This is the result that you should have had in the final step of this project. And I hope you enjoyed this video. Thanks for watching.